recording. Just real quickly, I think most of you have been in these sessions before, but each presenter has 25 minutes to present and 5 minutes for questions. It's fine to go a little under, should really try not to go over. Everybody who has questions, feel free to unmute yourself and ask the question out loud, or if you want to type it in the chat, you can do that as well. And sometimes it's nice to type out your question while the presenter is presenting, maybe in the notes app or something, and then just paste it in. That way we don't have to wait for some typing. For the presenters, if there is a question asked in the chat, if you could just read the question before answering, that'd be great. To the folks who are in the class, I sent an email to you with the peer review evaluation link, the capstone project library link, where you'll find all of the recordings. I will also include those links once everybody gets in this room. I'll include those links in the chat as well for anybody else who wants to have those. And we will go ahead and get started. So Lauren, whenever you're ready, you can go ahead.
Okay. All right, my name is Lauren Glenko, and this is my presentation on the Allegheny wood rat habitat suitability, and my advisor was Karen Schuckman. Start off with a little background. So the appearance of the Allegheny wood rat is a bicolor grayish brown with a white underbelly. They average 16 to 17 inches long with a 7-inch furry tail. They are classified as the second largest rat in North America. For their behavior, they're typically solitary animals, only coming together when they actually need to do during mating season. They are nocturnal, so mostly active at night, and they tend to build nests similar to birds, as in they're a cup shape with a hole in the bottom, a indent in the bottom and higher sides, and they do avoid humans. Some influencing factors to their habitat are predators. They are prey to raccoons, foxes, snakes, and owls. Their food source can be herbaceous plants, acorns, and the American chestnut. So the historic habitat for the wood rat extends along the Appalachian mountain range. They were discovered in 1887, but in the 1970s, there was a noticeable decline in them. This hasn't been narrowed down to one specific issue. It could be competition of other rodents. So they also self-limited their habitat range, as in their factors that they decided that their habitat was good for, they actually got them less. And during this time, the American chestnut actually suffered a significant blight. And there are not many, if any, American chestnuts left. Though they're one avenue of food, it was decreased. So the historic range for PA, this is a shapefile that was created by a retired PA Game Commission biologist named Cal Bukowski. He digitized these based on field verified GPS points and digitized using a geology layer. Onto the map to the right, you can see the active sites and the inactive sites. So the difference between the active and inactive sites is where they field verified that there are still Allegheny wood rats. The criteria they used are if they found nests and if they found latrines, which is just a specific location that they find their scat. And the inactive ones were historical places they found wood rats before, but they no longer find them there. And one thing to note about this map is the habitat ranges along the Allegheny and Appalachian mountain ranges. So my research question was, after identifying the habitat requirements, is it possible to predict locations of the Allegheny wood rat habitat? And one important thing to note is the Allegheny wood rat is actually listed as threatened by the PA Game Commission. For other entities, there hasn't been a consensus. They've had them listed as threatened, endangered, or even slightly endangered. So my area of study is the southwestern area of PA located in the map below. In this area, there is the Ohio Pile State Park, and that is primarily located in Fayette County. Some habitat characteristics are they have preferences for remote rocky habitat, which are caves, ridge crests, overhangs, boulder fields, rocky fissures, talus fields, and forest. On the image to the right are two images of a nest, and the bottom one is the latrine. Those are the markers that the biologists typically look for. And the image on the bottom is actually a talus field. And talus fields are a sloped terrain, mostly made up of loose rock. And rock cliffs and outcroppings at high elevation are also important. But one thing all these have in common is that it's a safe place for the Allegheny wood rat to put their nests, and they typically barricade them off, so there's only one entrance and one exit. So for my data, the input data listed from left to right is the geological data set. All of this was obtained from the Pennsylvania Spatial Data Set. The one to the right is the National Land Cover data set from 2019. And then on the bottom left is the 30-meter resolution DEM that was also from POSDA. And then the validation data for the habitat is listed to the right. Some of the changes that I had to perform when I was working with this data was I had to actually switch from a high resolution of 1 meter resolution DEM to low resolution, so a 30-meter DEM. This was mostly due because the processing time was astronomical. I was not getting anywhere. And the resolution of the other data sets, as you can see, is actually low. So when I was trying to combine high and low, I was not actually getting any data or getting anywhere. So this is an example of a sample methodology for the suitability modeler, which is what I've used. This image is from the ArcGIS online help for bobcat habitat. The basis of the tool is you define your goal, you provide your base criteria, you derive the data, transform it into a suitability, and then you wait and combine the data, and then it will generate regions. For my wood rat methodology, I took the wood rat habitat, broke it up to DEM, land cover, and a geology shapefile. I had to derive the data into slope and a geology raster because the geology wasn't a shapefile. I then transformed all three of them using the suitability modeler, and what they was transformed to was suitability rating. These were then weighted and combined, and then the locate tool generates the regions. So this is screenshots from the suitability modeler itself. You can see it has 3 tabs. The first one at the top is actually the suitability, and this is where you rate your data, and you can also transform it. And transforming it is just assigning the suitability. The bottom to the left is the settings, where you can select your model input type, you set your suitability scale, and weight by. So weight by percent is what I chose. You can also weight by multiplier. And then the suitability scale I chose from 1 to 10. You can do 1 to 3, 1 to 5. I did 1 to 10 because there were quite a few classes for the geology and the National Land Cover data set. And then the bottom right is the locate tool, where you specify your output, your region, which is how many shapes you would like, and then your evaluation method. So suitability modeler for slope, I was primarily looking at slope that was 10% or greater. This is mostly due to the fact that that was considered higher elevation. And this is an example of the transformation of the data. The suitability modeler for land cover. So the deciduous forest, the mixed forest, and the evergreen were listed as higher suitability. The low suitability were any of the developed or barren. Open water and herbaceous were weighted somewhere in the middle because they do tend to be, all these shapefiles had in common was there seemed to be water nearby. It didn't seem to matter too much to them, but having water meant a water source for them to drink from. But they also do like herbaceous plants for food, so I did rate that one as a 7 specifically, because that is a place for them to get food. And then finally, the geology. So the geology was how I came up with the suitability, was running a built-in query in the suitability modeler. I weighted it on forest and any slope greater than 10%. And this told me which areas had these specific types. There was only a few locations that were specifically only in one small location. The rest of it was spread out, as you can see on the image on the left. Again, there's those tables and everything were in the transformation tab. So in the suitability modeler, this is the locate tool to generate the regions. My result of the regions is shown on the left. So the locate tab identifies the best regions from the suitability raster, and the major type, the major evaluation method I chose was the highest average value. This takes the suitability map and takes the highest average value and then creates regions based on it. You can specify the number of regions. I chose 8. And then as you can see, it says the input suitability that was based on my suitability rating from the previous slide. So for my results, it generated eight regions, and these are not classes, these are just areas they picked on. So all of these areas are, as you can see, are actually in some of these state game ones themselves. They're slightly broken up, and then the table to the right tells you the grid code, which is just the value, and then I have acres reference. And this is the validating the results. This is overlaying the active and inactive layers with my predicted results. I did get a majority of them within the active habitat, but some of them, as you can see, were in areas that are not. And some interesting facts about the 7 and 6 regions is those are follow the mountain range. So I'd be curious to contact the research team and see if they've ever looked there. And then this is an example of the historic habitat overlaid with my study area and the active and inactive shapefile. As you can see, most of the regions did fall within the historic habitat. So there are factors that did line up with that. So I am not done. I need to do some further research, find some additional criteria. One thing I thought about narrowing it down to was specifically chestnuts as a source of food. There's also the percent of land cover or forest cover. Some papers were stating that the percent of forest cover is actually 10% or greater. So if I add a criteria for a forest canopy of 10% or greater, it may narrow down the areas. I will have to also verify with the PA Game Commission for habitat. I did get permission from them to use their GPS points that they were willing to give me to verify my data. I have not received these points yet, so that would be a next step. And then I'd also have to look into the talus slope exploration. As I said, The talus slope are broken up rocks and everything on a specific incline. The incline is listed as 10 to 35 degrees of slope, which would narrow down the range of that I'm looking for the wood rat habitat. I also will have to review the slope raster. There is an inconsistency I saw in there as I was putting it together, but I was not able to address it at the time. So the timeline is I did not pick a conference to attend just yet. I first have to do some future research and I will find a conference. I have one more class except for the 596B, and I aim to graduate in the fall of 2023. Here's some of my references. And then questions.
Great job, Lauren. Very interesting presentation. Does anybody have any questions? Remember, you can type in the chat or you can unmute yourself and ask the question out loud if you'd like. While people are typing, Lauren, do you have, I know you said you didn't find a conference yet. Do you have any particular ones in mind that of whether you're going to do a GIS conference or something more related to environmental, to species stuff that's not necessarily a GIS conference?
I did think about doing a more of a GIS. I was looking at the dates of some, and unfortunately, some of the ones that are more related to species are actually within the next month, and that would be a little too. It's like I don't think I can enroll in a 596B at that time, so
Right.
I have to reconsider that. Okay. So a couple of comments. I'm going to expand this. Could you present to people with the game commission? I could present possibly to the game commission. There's actually a professor from another university that was actually, his contact information was given to me by the manager that I spoke to at the game commission. And there's someone actually doing a verification of rocky habitat in the area I was looking at. I could reach out to him and see if they have any thoughts. So have you identified any gaps in the geospatial tool set you used based on your initial analysis? For example, what additions, extensions to current GIS platforms that help you do this kind of work more efficiently? The suitability modeler is a great tool. It does have some limitations. I wish it could actually do a little more with integrating shape files with it. It will only let you input rasters, and I actually had some issues of the platform crashing quite a few times. I'd have to redo the modeler. It's like I could save it and then open it, and I guess it got corrupted. So it was good, but I feel like it had some more bugs. So any natural predators a factor? So one factor that was listed, and there's not really, they can't narrow it down just yet. There's something called the roundworm that's gotten from raccoons, and it could possibly be causing issues. They said some of them have died for it, but they've also, every paper hasn't narrowed it down to just one specific problem. They say that fragmentation and then deforestation are just another issue, but they don't seem to have a consensus on one specific criteria for causing it. There's also seems to be changes with between the states. So what a wood rat in Pennsylvania might like, a wood rat in New Jersey doesn't particularly like. I've also seen other ones that stated that the habitat requirements have changed. And here's a comment. I remember in the image analysis class, I can cut the study area due to using 6-inch data. Yeah, resolutions are definitely an interesting, are a nice tool. So are there any more questions, comments?
In case anybody does have a question they haven't been able to type yet, or they're still thinking of questions, can you put your email address into the chat? That would be great. Again, nice job. Okay, so let me pull up our little schedule here. So next we have Catherine Hunt. So Catherine, whenever you're ready to start, you can go ahead and start sharing and unmute.
Can everyone hear me okay?
Yes.
Just share my presentation. Okay, good evening, everyone. My name is Catherine, and I will be presenting my capstone proposal. It's titled A Blueprint for Reducing Recurrent Traffic Congestion Through Routing Applications. And my advisor is Dr. James O'Brien. This is my presentation overview. So before routing applications, drivers only knew a couple routes between an origin and a destination. And outside of maybe radio broadcasts, drivers were largely unaware of real-time traffic conditions. With the advent of GPS-enabled routing platforms in vehicles, this is probably 25 plus years ago, traffic engineers and urban planners assumed that arming commuters with more information about the road network would allow drivers to make better informed route choices, and then that would result in reduced traffic congestion. So today, an estimated 1 billion drivers and growing worldwide are using navigation applications such as Google Maps, Waze, Apple Maps. Due to the large portion of drivers relying on routing applications, these platforms are increasingly influencing mobility patterns and the distribution of traffic congestion. The consensus now is that they're actually making traffic worse. So this is because routing platforms use what is called selfish routing. And it describes how routing applications choose the shortest route for a user without considering the route's effect on other drivers or the road network. Additionally, route guidance is often reactive to existing traffic rather than preempting traffic. And when routing drivers around congestion, applications often offload congestion from main roads to lower capacity local roads by giving all drivers the same quote unquote selfish route. So this problem that I described is encapsulated in Wardrop's first principle of traffic assignment. And this is developed by the mid-20th century mathematician, John Wardrop. And this is now a well-known concept in the field of traffic assignment. And so this principle states that drivers will choose the shortest route between an origin and destination as rational actors. And this creates what's called a user equilibrium in the road network where average travel time is increased. So a user equilibrium is a network suboptimal state or inefficient state. And this describes the effects of selfish routing. So if selfish routing causes a user equilibrium. So my proposed solution is based on Wardrop's second principle of traffic assignment. And this describes a condition or a state where each user chooses a road that is actually best for the road network. And then when they do so, the average travel time for the road network is at a minimum. This is what is called a social equilibrium, so the opposite of the user equilibrium. So my solution is to create a blueprint that demonstrates how routing applications can reduce congestion through socially optimal routing. So socially optimal routing is the opposite of selfish routing, where, as I just described, a user chooses a route that is best for the road network. And the outcome of this is a social equilibrium, which results in a reduction in average travel time and therefore a reduction in congestion. Since routing applications, as we've seen, are negatively influencing traffic patterns due to their large adoption rate, then the opposite should be true, that using the right approach, routing apps can positively influence traffic flows. This solution leverages routing apps' control over the traffic network to positively change traffic patterns. So here I'm focused primarily on what's called recurrent traffic, which are traffic patterns that occur regularly or periodically because they're easy to predict and therefore mitigate. So since rush hour is a major form of recurrent congestion, my blueprint will focus on rush hour traffic. So just some background on routing algorithms and routing applications. So the objective of most routing algorithms is to minimize cost. and cost can refer to any variable, but usually refers to distance or time. The image on the right is from a publication by Johnson et al. And shows routing algorithms that minimize different costs. So the simple route minimizes the number of turns, while the safe route minimizes the amount of high crime neighborhoods along this route. My proposed solution will focus on minimizing travel time, so time will be the cost. Dijkstra's algorithm is one of the most well-known algorithms for finding the lowest cost path. And it does this by iteratively choosing individual road segments with the lowest cost. This algorithm isn't made for complex, large networks. However, it is the foundation for the routing algorithms, the much more complicated algorithms that power Google Maps and Waze, et cetera. So routing applications can be categorized in a variety of ways, and not all of these are mutually exclusive. An application can share a few of these. So static navigation applications, for example, rely on predefined routes that are stored in the application. These routes do not change based on real-time information about traffic or road conditions. The given route remains the same. Dynamic applications, on the other hand, use real-time data to provide the user with the most efficient route based on current conditions. That means if the most efficient route changes as the user travels along the route, then the route guidance will change. So for proactive versus reactive, this is similar to static versus dynamic, yet slightly different. So with reactive routing, paths are generated in response to real-time road conditions. So for instance, let's take a driver that requests a route home from work during rush hour. The routing app will generate a path that avoids an existing traffic jam. Proactive routing, on the other hand, generates routes that minimize the likelihood of congestion. When a user requests a route home from work just before evening rush hour, a proactive app will assign a route that considers the likelihood of congestion, even though this congestion hasn't yet fully formed. And then centralized versus decentralized refers to the unit making decisions in the road network. So a centralized routing app involves a single point of control or decision-making, usually a central administrator or server. This administrator is responsible for directing all network traffic and deciding on the best route for vehicles to take. Decentralized routing, on the other hand, does not rely on a central point of control. Instead, the decision-making process is distributed amongst vehicles or in the network. And so each vehicle independently decides on the best route to take. So for my literature review, I looked at a variety of congestion reduction methods, some of which are infrastructure-based. So congestion tolls are one method, which are fees that are charged to vehicles for driving in areas of high congestion during peak hours. Building new roads is another approach. And while this creates more available capacity, it is often unfeasible due to cost or space constraints. Another option is optimizing traffic through bottlenecks with pre-signaling or lane assignments. And bottlenecks are points where traffic flow is restricted or reduced, such as a highway off-ramp. These infrastructure-based methods, while they can be successful, are met with mixed levels of public support and are often difficult to implement from a policy perspective. I also looked at works at literature that studied how choices of individual drivers lead to congestion outside of infrastructure-related problems. So in these works, game theory is often used to model the behavior of drivers as they make routing decisions. Each driver is viewed as a rational decision maker who wants to minimize their travel time, but their choices can affect the overall traffic network. So these studies show that the outcome of selfish, uncoordinated drivers and uncoordinated meaning acting independently is a user equilibrium, which is that suboptimal network state where everyone's travel time is higher. So since I'll be generating multiple routes from an origin and a destination, I looked at studies on how to compute alternate paths in a network. And these drew mostly from graph theory, since a road network is essentially just a large graph. So one is the K shortest path method. This is a graph transversal algorithm that aims to find the K shortest path between a source and a destination. And so K refers to the number of paths generated. So it could be 6 shortest paths or 3 shortest path method. So the algorithm starts by finding the shortest path between a source and the destination. Then it considers the next shortest path that does not share any edges with the previously found path. And it continues to do so for a K number of times. And then similar is a penalty method that iteratively computes the shortest path while increasing various edge costs or weights. And an edge is simply just a segment of a line. So I also looked at several studies that propose new socially optimal route assignment approaches to reduce congestion. So similar to what I'm going to do. So some of these works propose new routing algorithms for use in existing navigation system structures, and some propose new traffic management systems entirely. So how is my approach different from what I just discussed above, or what I read? So most of the literature focuses on optimizing traffic flows through one navigation application, but doesn't consider a situation where all major platforms employ the same approach. The literature presenting new algorithms are often primarily mathematical in nature and do not demonstrate realistic implementations within existing route application structures. My proposed solution takes a broader approach and examines all aspects necessary to a functioning, socially optimal routing platform. There's also a lack of research on how static, pre-generated routes can create large-scale stability and predictability in response to recurrent congestion, with most of the solutions focused on dynamic routing around small-scale traffic buildups. And then few works consider the route capacity when generating alternate routes. And I will talk about how I do so later in the methodology section. While there are studies that include portions of what I just listed, I did not find one that included all these aspects. So my goal is to develop an approach that demonstrates how routing applications can induce social equilibriums in the networks, thereby reducing congestion. So this includes a workflow and a Python software package based on the ArcGIS network analyst extension, and arcpy.nax is the related Python module. Then I will test the workflow and the script on a synthetic data set of routing requests. I'll use the city of San Francisco for development and testing. However, the script should be applicable to any road network. And during the testing, I will generate routes between 5 sets of origin and destination pairs to run the script. So my methodology occurs in 3 main workflows: preparing the network data, generating the routes, and handling the routing requests. So to prepare the network data set, I start with a polyline streets feature class. Then I identify the capacity related attributes in that feature class. If any necessary capacity attributes are missing, I join these to the streets data set. And then finally, I turn the streets feature class into a network data set and calculate the capacity of each segment. And so by capacity, I mean the maximum traffic flow that can be accommodated by a road in vehicles per hour. So what is a network data set? A network data set represents a transportation network and includes information on the connectivity, attributes, and costs associated with traversing the network. The network analyst extension requires a network data set to perform network analysis. So you start with the streets feature class or shapefile, and then run this through the create network data set tool in ArcGIS. So creating a high quality data set is time intensive. So therefore, I will use the sample San Francisco network data set from Esri's tutorial, and that's what you can see here on the right-hand side. So next, I calculate the capacity of each segment in vehicles per hour. To calculate capacity, you need to know the number of lanes, stop signs, traffic signals, speed limit, and road class. Esri's sample data set contained all of these variables except for stop signs and traffic signals. I downloaded this missing data from San Francisco's OpenGIS portal and joined it to the network data set. And then the actual calculations or the actual equations came from the Federal Highway Administration's Highway Capacity Calculation Method Guide. So the next section is generating the routes. First, I create the origins and the destinations. Then I find multiple routes between each origin and destination using the network analyst route solver. And then once the routes are created, I find the relative capacity of each route. So rather than generating routes from individual addresses, I will group similar origins and destinations together into polygons and create routes from these polygons. So these polygons are census tracts backed up with LEHD program data. And this is the Census Bureau's longitudinal employer household dynamics data set which contains information on the dynamics of employment, earnings, and job flows at various geographic levels. So using the Census Bureau's LEHD Online Explorer tool, I agglomerate the data at the census level, and then I download it as a shapefile. And the result is what you see on the right. So the pink census tracts have the highest job density in San Francisco. And the yellow census tracts are where the highest number of San Francisco-based employees live. So the yellow census tracts are the origins, and the pink census tracts are the destinations during morning rush hour, which represents employees leaving their homes and traveling to work. And then this would be reversed for evening rush hour. I will choose a sample of these census tracts for the analysis. So I won't use all of these, but the ones that I do choose will come from this map here. So next, I generate a set of routes from each origin to each destination census tract using the Network Analyst route solver. Using the k-shortest path approach, I generate multiple routes by running the route solver multiple times. The first route is the lowest cost path, or the shortest path, and the rest are alternate paths. After a route is generated, I add it as a line barrier, then run the solver again. This ensures that the route solver creates original routes. New routes can intersect or share edges with previously generated routes, but if they do, they incur a time penalty. The image on the right is from my sample route generation script using 3 origins, which are in the yellow, and 3 destinations, which are in the red. To ensure routes are realistic, alternate routes can't be more than 20% longer in minutes than the main route. Once the script can no longer generate routes from an origin and destination pair that meet this criteria, it stops. So then I determine the percent capacity of each route. So I first find the total capacity of all the routes between an origin and a destination. So that could be 2 routes or 3 routes. Then I find each route's percentage of total capacity to determine the relative traffic flow each route can handle. And then all of this information gets stored in a dictionary. So the final section is handling the routing request. Since route guidance is static, new routes are not being generated in real-time response to requests. Creating the network data set and generating routes all happens in preparation for handling the routing request. So the script for handling routing requests is separate from the script for route generation. So when a request comes in, the script first checks to see if the request meets certain criteria. The request must be within an hour, plus or minus from rush hour. The time buffer around rush hour prevents this congestion from building or in the first place or getting too bad. The request must also fall within the high capacity origin and destination census tracts that I showed a couple slides ago. If all 3 of these criteria are true, then the script continues with the request. So then the script refers to the route dictionary to determine the available routes based on the request specific origin and destination. And a sample of this is the top white box below. So the script sends a volume of traffic flow down each route relative to a route's capacity in groups of 10 requests. So in that route dictionary that you see on the screen, the first route can handle 40% of the capacity, and the second route can handle 60%. The script assigns the first 4 cars to the first route, and then the next 6 cars to the second route, then resets for the next 10 vehicles. I chose the number 10 because it sends a continuous flow of traffic onto all available routes. So rather than just sending a flood of vehicles down one route and then waiting and then down another route. And then simultaneously assigning both the best and the alternate routes helps distribute demand evenly and reduce the likelihood of any one route becoming overwhelmed by traffic demand. So the script is not complete. It's probably about 40% complete. It hasn't fully been tested yet. I'm drawing my anticipated results from the literature. So the image on the right-hand side is something similar to what I expect to produce in terms of route generation. This shows 3 different routes between an origin and a destination. The purple is the shortest route, or the path that drivers would take if routed selfishly. The other 2 routes are more socially optimal. This comes from a study by Kolek et al., who found that socially optimal routing marginally increased time savings for individual drivers, but reduced collective drive time of the network up to 30%. So this increase in time savings doesn't include an increase in driver satisfaction, reduction in frustration from sitting in traffic, reduction in emissions, and increase in air quality. So another study found that the proposed algorithms, which were socially optimal routing algorithms, were effective even with a low compliance rate. So I would expect even greater results if this approach is adopted by the majority of routing platforms. This is my timeline and possible venues. So from now until June, I will write and test the script. This summer, June to August, we'll complete the paper, and then fall 1 semester, take 596B and present. So ideally, I would get this work published in one of these journals. And if not, here are 3 possible presentation venues with timelines that line up with fall 1 semester 2023. These are my references. Questions? I think there's a couple in the chat here.
Thanks, Catherine. It might be the
Oh, yeah.
post that I did. Yeah. So I did miss a question from Fritz last time, so help me when people are posting questions. I'll have to try to double check, but there's a question from Fritz this time, so we won't miss it.
Okay, so this from Fritz, this may be a bit beyond the scope of your presentation, but how would you consider including live road condition updates to your algorithm? So yes, I did consider this initially and realized it was beyond the scope of what I could do. So that's why I decided to focus on recurrent traffic, which is, such as rush hour traffic, or maybe holiday traffic or something like that. That way I could pre-generate these routes, and they could be, stored beforehand, and, I could really make sure, or by me, I mean, maybe the application using them can make sure that they made sense beforehand. And I also, in the research paper that I've written up to go along with this, have a whole section on, future work and how routing applications can adopt this in a realistic way. And one of those is dynamic routing around things like live road condition updates. So and still being able to do so while maintaining that social equilibrium. So that is definitely in the future work section. So from next question is, do you think plus or minus 1 hour of heavy traffic might be too large of a buffer, being 1/12 of the day? Or could you look at testing 30 minutes plus or minus of traffic? So I think really it would depend on the city. So for San Francisco, I need to look into probably, I know their rush hour is about 6 to 9 in the morning, and about 4 to 7 in the evening. Probably look at traffic and see when it starts to build up, and really fit that to each city. I know where I live, traffic starts to build up probably around 2 or 3 p.m. So that was just based on my own personal experience, but that number is definitely subject to change.
Any other questions? I was curious if you're going to, even if you get accepted to one of those publications, will you also present, or do you think you'll?
Yes, I would definitely try to do both.
Great.
Yes, and I know it takes a while to get accepted, so I probably would end up presenting anyways.
Right. And we normally have a good number of people at GIS in the Rockies, so that might be nice. You might be able to see a few other students there as well.
Great.
Any other questions? Oh, there's one from Anthony.
I spent some time living in Austria a few years ago, and the summer camp traffic coinciding with school holidays in Bavaria was such a nightmare on the local Autobahn near Salzburg that the authorities prevented anyone from exiting the highway who had a non-local license plate. Are you aware of anything similar that has been attempted in the United States? No, I really haven't. I'm not aware of that at all. The closest thing, which is not really the same at all, is, the congestion toll. I know that like London is a very famous example of the congestion toll. So that's not the same, and that's also not the United States. But other than that, that's the closest thing I'm aware of.
Okay, well, maybe you can put your email address into the chat. And there might be some other questions that are coming in or that people are thinking of. So thanks again, Catherine. Very ambitious. It looks, I'm excited to hear how it turns out. Okay, so the next project presenter is Eric Martinez Luna. So Eric, whenever you're ready, you can go ahead and start.
Sure, thank you. All right, can everybody hear me?
Yep, and we can see your slides.
Cool. So, hi, my name is Eric Martinez Luna, and I'm going to be presenting my presentation, Paving the Road with Automation, and my advisor is Dr. Panos. So a little about me. My name is, like I said, my name is Eric Martinez Luna, and I'm currently in Austin, Texas. I grew up in Austin, and most of my life, and eventually I went to Texas A&M to obtain my undergraduate degree in GIS. And I'm currently employed by the Texas Department of Transportation as a GIS analyst, where my daily duties include management of route information, map creation support, and workflow automation. And I have a little over 3 years within the transportation field and 6 years of GIS work experience. And a fun fact about me is that I have a zoo at home with 2 corgis, 1 border collie blue heeler, and a really big cat. And just as proof, here's a picture of my cat, Mia. Not quite sure what she is, but she's seen as the alpha from all my other dogs. So the objective of the presentation is to provide a background to TxDOT and a little bit about our database workflow, discuss our basic roadway model and our workflow in maintaining the route information for that model, identify the roadway workflow problem that's within our workflow, present the proposed application for automating the snippet of our workflow, and present my proposed project schedule. So as I said, I work with TxDOT, who maintains the whole Texas roadway system. The roadway system includes roughly 80,000 miles of on-system roadway. And when I say on-system roads, I'm referencing those that are maintained by TxDOT and receive federal funding. Roads such as local streets, country roads, and private roads are considered off-system. So we don't really track them for federal submission. Since Texas is such a large state, the roadway system is divided into 25 districts, and each district is divided based on areas with their large population centers. And each district maintains their own portion of the network, and they'll send their information to the Transportation Planning Programming, which is my team in Austin, Texas. And we're usually responsible for geometry, for route geometry, asset attribution, and reporting of the whole roadway inventory to the federal government. And so all this data editing is maintained and stored within a proprietary software known as the Geospatial Roadway Inventory, or what we call GRID. So a little bit about GRID. Within GRID, descriptive data such as physical and categorical information for a route are stored within a series of individual tables that we call assets. So some example of assets are stored that are stored within GRID would include stuff like median type, number of through lanes, maximum speed limit, anything along those lines we record. And in total, there's around 33 federal submitted tables that we track, and there's a lot more that we don't submit, but we do record. So these assets are referenced along a route using a linear referencing system. And for those that don't know what a LRS is, it's where a line is segmented to behave like a number line. So an asset of X would exist along a route at position Y and N in position Z. So how are these assets updated within GRID? Well, analysts have two options. The first is through manual attribution through a GUI within the GRID portal. And this involves the actual manipulation of the begin and end values of that asset along a route. This can be done either through dragging and dropping the bounds of that asset along that route, or they can manually input the value of the begin and ends of where they fall along the route Another method that is used is extracting the asset information from grid into tables within ArcGIS Pro, and then manipulate those tables. And once that table is manipulated however we want, we push those tables back into grid through an ETL process. So updating of the route's asset attribution is required every time a route's geometry is adjusted or when a construction has been done on a route. So this is usually divided between, this is usually done at the very beginning of our editing season that starts at the end of April. So now that y'all have a general understanding of the work that we do within TxDOT and about grid, let's look into an example of a basic roadway model that we follow during attribution of a route. So this is a very basic model that we use for for attribution for a single roadbed that gets divided into two different roadbeds and then back into one roadbed. So at the start of the imaginary route, where only one roadbed, there is only one roadbed that we call the KG. We attribute the segment from the beginning of the route until the route splits into two different roadbeds, the left and the right roadbed, or the LG and the RG. So with the split of the roadbeds, each roadbed is usually divided with some sort of physical median. Attribution of the right and the left roadbed are independently done since they are on their own linear referencing system. So when I say when they're on their own linear referencing system, if the split of the divided roadway happens on the, say, on the KG at mile 1, instead of the LG starting at 1, it would start at 0. So their LRSs are independent of each other. So with the divided roadway, the KG turns into an artificial center line, and the continuation of this the KG line work is important because the line work will have its own set of attribution to satisfy federal submission and review. So with that being said, how do we attribute the artificial center line since it's just an artificial center line? Well, our current workflow is to manually duplicate the assets from the right roadbed, which is the dominant attributor for that center line, and place them within the artificial center lines tables. In a perfect world, the right and the left roadbeds would be splitting off at the center of the exact same spot, but due to how line work could be digitized and occasionally how routes are built, they don't exactly line up together. So in areas where the right roadbed is shorter than the left roadbed, the left roadbed's attribution will be used, kind of like what we're seeing in the diagram on the left side. So with this understanding, let's look at an actual divided roadway with an aerial imagery. So in the imagery, the black line representing the KG ends where a median begins, splitting the roadbed into a left and the right roadbed. The center line continues as an artificial center line, and the two roadbeds are now being tracked separately with their own set of attribution. So with this basic level of knowledge into our roadway model, you must be thinking, why is this important? Well, maintaining grid is important to ensure roadbed attribution is accurate. With accurate data, we can support all TxDOT projects and future efforts. And lastly, that's how we get funding from the federal government to maintain our existing network and build future infrastructure. So at the end of our editing year, at around April, because federal submission is April 15th, the Texas Roadway Inventory Network is submitted to the government for review. This review will demonstrate the performance of our network, update federal network systems, such as the National Highway System, and provide other statistical information that they need. So without accurate data, we want to be able to maintain the large network that is within Texas. So with all this being said, there's one big problem with our current attribution workflow and grid. Attribution of that artificial center line is a time-costly effort. So when grid was being developed, functionality to transfer attribution from one roadbed to another was not developed. So since the artificial center attribution must mirror that of the right roadbed, the actual attribution must be done manually through Grid's GUI every time a new route is added to the network or if a route isn't being maintained. So since Texas is a very large roadway network, like I said, we track 33 different assets to be submitted to the FHWA and a whole other suite of assets that we track So by manually attributing the artificial centerline, it also increases the likelihood of introducing human error to the database. So whenever anyone on our team discusses this problem with anyone outside of our team, we always get to ask the following question. Why not just copy the attribution from the right roadbed and paste them within the ETL packet? And our answer to that is usually we wish. Since each roadbed is independent of each other, they have their own linear referencing system. So we don't necessarily know where they exactly fall along that KG of the route. So we need to manually adjust each asset attribution through visual inspection within Grid. So my proposed solution to this problem is to create a custom Python application that will automate the attribution of the artificial centerline of a requested route anytime the route needs to be maintained. The application will use the right and left roadbeds, asset attribution, and build the artificial centerline with their current assets. And as I said previously, the right roadbed will be the dominant attributor of that artificial centerline. So in theory, the application will be use the geographic bounds of an asset type and snap to the route's artificial centerline. With that snap, we would be carrying over the asset attribution from the right and left roadbed to the artificial centerline. So what I'm envisioning is the application taking advantage of Grid's ETL capabilities and manipulate the extracted asset tables and push the newly generated artificial centerline into the database. The proposed application will be included within the current custom-built ETL tools and aid in the ETL function of asset attribution. And a little fun fact about our ETL tools, we label them as BLT, and we usually follow sandwich terminology for every tool that we have. So a little fun fact. So by automating the process of attributing the artificial centerline, the amount of time that a GIS analyst would take to attribute a route would drastically be shortened, and the likelihood of introducing bad data to the database would be minimized. So with the proposed solution, after having a discussion with my team, we came up with a few must-haves that the script should contain. The first is when the attribution of the artificial centerline is being built, the right roadbed will be the dominant attributor. When the right roadbed is shorter than the left roadbed due to how the route was digitized, the left roadbed attribution will be used. The second is that the application must have the capability to identify and correct asset logic violations. So an example of a violation could be a route cannot be attributed to have no shoulder type, but have a shoulder width greater than 0. That doesn't make sense. Another one would be having a median type of none and having a median width greater than 0. So the majority of these asset logic violations will require manual intervention, but for some assets like median width, since we were able to identify where the split of the divided roadway happens, stuff like that can be automated and corrected through the application. So the final functionality that should be implemented is the ability to dissolve records. So what I mean by that is if two neighboring assets are the same asset type, such as if you have two neighboring records that have the same outside shoulder type, these two records will be merged to be only represented by one record. This is important to lower the amount of storage that's being used up within the database from the existing attribution. So once these functionalities have been met, some future considerations would include a separate script that will test the integrity of the built attribution. This could be through referencing past attribution to the proposed attribution and highlighting any introduced errors or display corrected asset attribution. And another functionality that my team was requesting would be if the functionality of the proposed application could be reversed, meaning if the attribution of the artificial centerline is known and the right and left roadbeds are freshly digitized, to attribute the other two roadbeds with default values from the artificial centerline. So with this basic functionality of the script defined, the next step is to develop a workflow for how the application will operate. So the first step that the application will do is allow a potential user to select a route within the Texas roadway inventory. Once a route has been selected by the user, the application will query Grid to extract the KG, RG, and the LG roadway asset attribution and the geographic information. So with the extracted geographic information for that KG, line work will be generated for the live data referencing. With extracted geographic information from the right and left roadbeds, a point layer will be created highlighting the begin and ends of each asset type. So the point layer will then be used to identify their nearest measure value to that on the generate KG line work. These measures will be used to generate a list of begin and end bounds where the roadway begins, where the roadway becomes a divided roadway. So with each point having the nearest measure, they're located to the KG line work, the application will then build the artificial center line using this information. And as the attribution is being built, the RG attribution will be the dominant. Unless not available, then the LG attribution will be used. So with the table containing the built attribution for that artificial center line, the application will create an ETL packet for the KG attribution. The application will then remove all the attribution that's currently existing within that artificial center line and delete those from the packet to make room for the attribution that the application is building. So once that packet's prepped, the application will then push the built attribution to that packet. So then the final step after the packet has been prepped or the artificial attribution has been pushed in, the last step will be to iterate through that ETL packet one more time and dissolve any contiguous assets with more than one record. So through this process, the result will be an ETL packet with the attribution of the artificial center line fully automated. So in summary, accurate data is really important for TxDOT projects and future endeavors. And the big one is that it's really important to receive in obtaining federal funding for the state's roadway network. The big problem that we face is that the attribution of that artificial center line is time costly and increases the likelihood of introducing human error within into the database. And the solution would be to automate the attribution of the artificial center line by using the left and right roadbed attribution within the ETL packets. So as far as the project timeline goes, I'm planning on beginning development as soon as possible, since right now we're wrapping up last year's federal submission. So that way I could get started when editing starts in, I think we were talking opening up this year again in August and so once the script hopefully gets started for that editing season, hopefully it'll cut back a lot of time from each analyst that goes into attributing routes within grid. My manager is really eager to get this application up and running just because of that. And as for potential conferences, I would like to present my capstone. I have my eye on the GIS forum in October in Austin, Texas. That's around the same time I'm going to be taking the second part of the capstone, and potentially the Azure User Conference, since some of my team members are also looking to present some of our things at that conference, and it'd be great for me to go there as well. But it all depends on the development status of that application. But thank you for listening to my presentation, and if you have any questions, please let me know.
Great job, Eric. I just pasted my questions in there, and anybody else, if you want to add some too, please do.
Sorry, I'm trying to pull it up, but my computer is not being supportive.
If you hover over the top part, you should be able to.
Sure. Okay, I pulled it up. So you said, are you only talking about road segments that have medians? Yeah, so right now, the script would attribute divided roadways for our whole network. For anything that's outside those medians, I'm thinking that my script's only going to correct some logic violations. But as far as the main purpose would be only for road segments that have medians. And since a huge portion of our network are routes with medians, it's going to be drastically cutting down on what we have to automate for that route, for our network. And then the second question is, how much of this work has been done manually prior to developing this tool? Everything. Everything's been done manually. If you ask anyone on my team about it, they'll groan and complain that is their least favorite thing to do in the world because it's really boring. And it requires a lot of referencing of, since you do have to manually do the RG and the LG, it requires a lot of referencing of documentation, aerial imagery, things of that nature. And just having that extra step of, okay, well, I got this now, I just got to copy it again to the center line. It's a really annoying process. And then the second is, I'm curious about how the inventory network changes from year to year. Do you have any idea of how many more road segments will be added as a result? That question is a little hard to answer. Every year, there's a lot of stuff that happens. The districts and even people just looking at our data will send us notifications of what needs to be updated. And we have our own tracking of our inventory as well. And so it depends on yearly what we have to do. And usually it takes us the whole editing season just to keep up with what's going on with the whole state. So the next question is, for future divided roadways, are there, or those under construction, is there a way that these could be entered into grid system differently that solve the attribution issues from the start? So the cool thing about the routes that are under construction, well, I say under construction, and we have two different definitions. One is if a route's being used under construction, we attribute those the same way as a route that's fully built. But if a route's being freshly constructed, it's new, or if it's proposed, we don't really track their assets until it's completely done. But as far as entering their assets attribution goes, from the very beginning, it would have to be manually done as well. Since a lot of that data is either aerial, or there's just different avenues where we get that data and they don't really talk to each other. And it's a lot of digging just to get that data. So that's why it's a little hard to automate everything or make things a lot easier.
In case somebody else is typing, I'll ask one more. How long has this been on the wish list for you and your coworkers and your supervisors? And
honestly, it's been since Grid was made, because a little sad thing about Grid, it's a little bit of my bias as well. I don't really like Grid, but I since it was created, a lot of people have been complaining about how inefficient it is. And so when I proposed this to my manager, I could tell how excited he got. He said, "Can you get this started now?" And so they really want this to be up and running as soon as possible. And yeah, they're really excited for it, but they've been wanting something like this for a long time.
And I'll ask one more. Do you know if any other states are doing this, or will you be sharing this with other departments of transportation?
So I'm not sure if other states are doing this, because other states have their own process of maintaining and submitting their inventory to the federal government. And the reason why we track this artificial centerline is because they require that, since they have all sorts of different systems going in. They just want all that data available to be able to like compare between states. As far as what they're doing, whenever I spoke to my manager about this, because he previously reached out to other DOTs to see how they're doing it, they all have the same answer, that they say they do it manually. So just automating this would be a huge win for us, as in allowing us just to do what we need to do outside of having to copy attribution over.
That's great. It sounds like something that other states will want to hear about.
For sure. Yeah.
Okay, well, great job. If you can go ahead and put your email address in the chat, then there might be some other questions coming in.
For sure. Thank you, everybody.
Thank you. Okay, up next we have Ross Rogers. So Ross, whenever you're ready, you can go ahead and start.
Okay, good evening, everyone. My name is Ross Rogers, and I'll be going over mapping a radio frequency from space. This will be a case study into developing a national RF map. So a little bit about myself. I'm a geographer for the U.S. Geological Survey. I support the Civil Applications Committee, which facilitates the appropriate civil use of overhead remote sensing technology and data collected by the military and intelligence capabilities, including commercial sources. I'm also a Naval Reserve officer supporting the National Geospatial Intelligence Agency and Command Pacific Fleet. Fun fact about myself, which I had the privilege of, is being a park ranger at Yosemite National Park in 2017. And when I'm not doing grad school or being a geographer or a naval officer, I'm with my family. So looking forward to getting grad school over with. No, the objectives of this brief are going to be an overview, then go over the objectives of my research, my methods, the products that I intend to develop, the timeline and milestones that I'll be looking to achieve, some of the assumptions that that my research will have made, and the procurement, as well as my references. So for an overview. So the radio frequency spectrum is ambiguous worldwide due to its widespread use in cellular communication towers, wireless networks, radio transmitters, and other devices and infrastructure. However, traditional methods of mapping the RF spectrum are highly inefficient, involving physical surveys and terrestrial locations, or relies on the accuracy of crowdsourced data to generate RF signal propagation maps, like you see on this chart. So understanding the RF spectrum is crucial for creating efficient and effective communication infrastructure, mitigating signal interference, identifying coverage gaps, and making informed decisions about communication network strategies. Furthermore, it can provide insights into temporal aspects of human geography, impacts on the infrastructure after a disaster, possible conflicts or nefarious actions, and assist in the research in the environmental or health impacts of RF transmitters. The advancement of commercial space RF sensors by companies such as Hawkeye 360, Maxar RF Solutions, which was previously known as Aurora Insights, Cleos, Predasar, and others will be revolutionizing commercial infrastructure. These sensors can collect accurate and actionable RF spectrum data over a wide area of coverage with high fidelity and incredible speed. As a result, they will offer valuable insights into the RF spectrum landscape. To improve our understanding of the RF spectrum landscape, I'm submitting a project proposal and case study exploring the feasibility of creating a national RF spectrum map using advanced commercial space RF sensors. The research would involve a market assessment and selection of current commercial space RF sensor providers, provide 2 to 3 sample sites to test and develop a standardized process generating the RF spectrum map, and determine the requirements for implementing a national collection strategy and implementation of a national RF spectrum map in the United States. So this image here is just a kind of a concept. I'm using High Five, which is Department of Homeland Security's database with cell phone towers, creating a simple heat map. So this is just kind of what it would look like, one at a large scale or small scale, and then a large scale, you could start getting a finer detail. So other phenomenologies that kind of already do this is the National Transportation Noise Map provided by the Department of Transportation. And so again, different spatial resolutions, you can start teasing out. That is Penn State. I'm sure all of you know that as well, to stay clear of airports because they're quite noisy. So again, another phenomenology using VIIRS nighttime to show light pollution. Just different aspects of these maps that could be produced. So the objectives of my research. So first, I would be identifying the commercial space RF provider. that would assist in this. And I'll be going into further details in these 3 objectives in later slides. So the next would be develop a standardized process to generating the RF spectrum map, and then report on the recommendation, implementation, collection strategy, as well as the National RF Spectrum Initiative. So for identifying, so I would develop collection requirements needed for developing the RF spectrum. So that would be a daily refresh of a given site, the dwell time, understanding what different dwell times would do with that space sensor. And then I would also be looking at the feasibility of the maturity of the constellations and the frequencies that those sensors can actually acquire. The next, I would submit for collections for 2 to 3 sample sites. Hopefully, it would be a urban, a metropolitan, and a rural area to understand different aspects, and then receive collections for the 2 to 3 for post-processing. So my third objective would be to standardize this process. So I'd be looking at establishing a heat map of RF spectrum across the sample sites, create a 24-hour approximate average for RF spectrum. And then I would compare these with the traditional RF signal propagation and loss terrain analysis tools. Mainly, I'd be leveraging the Longley-Rice propagation model, which is good for 20 megahertz to about 20 gigahertz, which is great for communication RF transmitters. So the third would be to create a report of my findings, and not only create a report, but also develop a national RF spectrum map initiative. This would be developing a handbook. Basically, I would turn over to probably the FCC and put it with a collection strategy, identify storage requirements, identify, sorry about that, identify storage requirements, identify processing requirements, and generate a post-processing standardization procedures, web hosting services, and then create a estimated timeline of national RF spectrum completion. So the methods that I'll be using for this is one for the feasibility study. I'll be assessing for 3 primary factors, which is spectrum range, maturity of constellation, and access to the sample data. So the spectrum range that I'm looking to receive or collect on is 225 megahertz to 7.125 gigahertz, which is the federal government spectrum use for national communication and information administration. So the next is, are they operational constellation satellites? Are they currently in orbit? Some of these companies are still launching their satellites. So understanding maturity of what is available up there. And then I must have access to the sample data. So either the data set will be submitted through established government processes through the Civil Applications Committee, or directly with the vendor themselves. And then third would be my methods for developing the RF spectrum heat map. I would be leveraging the Institute of Telecommunications Science for the propagation modeling website, or PMW. This would provide shape files. I could do KML and stuff like that, but we all work within ArcGIS, and that's what I'm more familiar with. So I'll be leveraging that model site and leveraging or providing validity to the Longley Rice model and compare and contrast what is actually being collected. Then I'll perform raster calculations, basically doing total number of transmitters within a given resolution, or the RF power that's within that spatial resolution. Those two things could decide whether is an area is being flooded by the same frequency, getting noise, step on, and comm degradation, as well as given absorption power within a given range. So then I would perform a 24-hour calculation to determine an established spectrum to use. So for my development report, again, it would be very basic. A collection strategy is the #1 driver for most space collections. And so developing an established collection requirement, identify the storage requirements for these collections, and then the processing requirements for the PMW, if it'll be able to handle the amount of data, generate a post-processing standardization procedure, and then web hosting for actual public use of these maps, and then generating an estimated timeline for this collection. So the products that I'll be producing: the feasibility study of the RF spectrum map, or the feasibility of the commercial RF sensors, then developing the RF spectrum heat maps for the sample sites to operationalize and test my processes, and then develop the recommendation for the National RF Spectrum Initiative. So the timeline I look at doing will be in 5 phases. So identifying the provider, which I've been doing already. Once that provider is selected, I'll go through establishing a collection requirements for 2 to 3 sites. This should take around 2 to 4 weeks. But being collected is dependent on what is currently being tasked. Develop a post-processing standardization procedure. And then phase 4 would be the generating the report and recommendation for the National RF Spectrum Map Initiative. And the final would be present my research findings. So again, I don't have to, it's a cascading phased approach. One can't be completed without the other. And so that's what I'm looking at. So, and then the milestones for this research project would be identifying, if it's possible, with the current provider constellation, which it is looking like it is. Then submitting that collection plan, and then developing the RF standard process, and develop the national collection strategy. The assumptions for this project are commercial space RF sensors are mature to meet these collection requirements. And then the assumption is access to these sample data sets, and then the RF space sensor data supports the requirements to run within the PMW. If not, I can, once I receive the data set within ArcGIS, do some local calculations with different modeling applications. So for the procurement, this is pretty simple. Commercial space RF sensor providers, capabilities and limitations. Those are already in the standard forms. The National Reconnaissance Office, as well as the National Geospatial Intelligence Agency, creates these wonderful commercial reports that go over these capabilities and limitations of these providers. Access to the sample data sets, And then access to the PMW, which established already, and then the ESRI license, which at USGS we already have. So again, my references are provided. And any questions?
Great job, Ross. I posted a ton of questions, but feel free to go to others if other people type in a lot, then you don't need to answer all mine. I just wrote them down as I thought of them.
Let me pull that up. Sorry. It's a mini control. Okay, the commercial companies mentioned, do they collect just certain portions of the county? So no, they don't. It would be up to the tasking of the commercial provider. These would be submitted through the NRO office, through the CIDR process, and basically I would provide a AOI, area of interest, and to collect this. They are already currently collecting. I know Hawkeye 360 is, as well as Aurora Insight. I've seen some of their products already. Is that why it doesn't exist? No, it definitely exists, and I actually find it very interesting that there hasn't been an RF national map out there already. I know in my research through the EPA, there was an initiative a few years back that actually got disestablished, and so and they are looking forward to maybe this reinvigorate this. Let's see. Is the idea to approach each of commercial providers and get quotes? No, ma'am. This would be again working with within the Civil Applications Committee, which we do the facilitation of remote sensing. The contracts would be provided through the National Reconnaissance Office, which has a much larger budget than USGS to be able to get these collections. Do they fund it? I think I answered that. Can they get the constellations from other providers? The other examples you mentioned, like noise or light, did those come about in similar ways before? They were national maps. So for the light pollution, that's just a simple collection and of a electrical optical sensor. They were able to, so VEERS was able to capture those. I believe there's another satellite that also assists with that collection, but it's just when the satellite flies over that area and is still collecting and not sunbathing or recharging its batteries. For the noise pollution, that was to understand. That was the history of that. I'll need to dig in a little bit deeper, but I'll be able to get that reference to you. I have it on my desk. Do those come in similar ways? A very practical application. This may not be Apple, but could your study be useful to those who use shortwave radios as well? Absolutely. So really, it's looking at the spectrum. So looking at the power as well as the frequency and seeing how low of a frequency these will be. A couple of the case studies that have been brought to my attention is RF RF tracking of caribou with chronic wasting disease. That would be another application of leveraging RF sensors, space-based sensors. And then what challenges do you think be posed by trying to deal with temporal aspects? You know, that's a great thing is when I initially got interested in this project, I was at USGIF GeoInt Symposium, and one of the main talks was on RF sensor providers. And so really, I started thinking about it, and I was like, the temporal aspect of a football stadium with football being played, vice the groundskeeper mowing the grass is vastly different for RF. So these sensors aren't like the EO constellations that are up there right now, where you know, you can almost get a daily refresh. But definitely collecting at different times of the day will be able to show different phenomenologies like movement within city centers. You'll be able to understand when comms start to get degraded from oversaturations of users. We've all, if you've been at a football stadium, we all understand that is a very real issue. But yeah, that's how I came up with this, because RF is definitely a temporal phenomenology, but so is sound. And so understanding a baseline and creating a baseline a map would be a first start, and then being able to refresh that to account towards the temporal aspect. So if you have any more questions, please let me know. Oh, if I do look at presenting these findings, this would be a, even though these are unclassified sensors, it would fall underneath the controlled unclassified information. The Civil Applications Committee does host meetings for about 150 folks. These are unclassified meetings. They're hosted by the director of USGS, Dr. Applegate, and I would probably present there. I know for those meetings, I would have representatives from the U.S. Department of Interior, Agriculture, Commerce, Health and Human Services, Transportation, Agency for International Development, Army Corps of Engineer, Coast Guard, the EPA, FEMA, National Science Foundation, NASA, Tennessee Valley Authority, the State Department, the Energy Department, or Department of Energy, Department of Homeland Security, National Reconnaissance Office, Defense Intelligence Agency, National Geospatial Intelligence, and the National Guard Bureau. We might have members from the Director of National Intelligence, as well as the Office of Science and Technology Policy and National Geospatial Intelligence Committee.
Okay, great. Thank you, Ross.
Hey, thank you so much.
Okay, I don't see Danielle in here. We're running a good bit early. So Grace, I don't know, are you ready to go next? Would you be able to go next, and then Danielle can go after you?
Yep, I'm ready to go.
Excellent. Thank you so much. You can go ahead and share whenever you're ready.
Okay, good evening, everyone. My name is Grace McMillan, and my capstone will be predicting the fall of a region, a spatio-temporal analysis of Russia-backed separatists in the Donbass. My advisor for this is Dr. Gregory Thomas. During this presentation, I will brief the background of the conflict in Ukraine, highlighting the events from 2014 to present day. Once I have given a small historical background, I will then dive into the importance of this project and what I hope to accomplish. The goals and objectives of my project will be stated, and I will ensure to explain how this project is not only important to establishing a baseline of areas of risk, but also how additional areas can be predicted. My research is centered around one primary methodology, so I will explain a similar case study and how I anticipate to use it for my project. Finally, I will talk about my timeline and possible venues for this presentation once complete. So most everyone is generally familiar with the country of Ukraine. However, I'd like to orient you to a brief geographic introduction. So Ukraine is the second largest European country with a population of approximately 43 million. It's bordered by the Black Sea to the south, Poland to the west, Romania to the southwest, and Moldova to the west. And then of course, Russia is to its east. Over 70% of Ukraine's land is dedicated to the agricultural sector, with wheat being the largest produced crop and also export. Going to its demographics, Ukraine is comprised of 77% Ukrainians and 17% Russians. The government of Ukraine is a semi-presidential republic, with the chief of state being the head of the executive branch, currently President Zelensky. Ukraine's presidential elections and political movements directly contributed to the start of its conflict since 2014. So in November of 2013, the Euromaidan protests began due to the suspension of Ukraine signing the EU association agreement from pressure from Russia. In February 2014, an agreement was reached. However, it caused the removal of the president, and a new interim government was forced under a new president. However, the crisis didn't stop then. Russia illegally annexed Crimea, and secessionist movements started in eastern Ukraine. This area, the Donbass, will be the focus of my research, since it has been occupied for almost a decade by Russia-backed separatists and now Russia itself. Currently, as most people are aware, Ukraine is in a full-blown conflict with Russia. The areas that are under full control by Russia are Crimea, Donetsk, Kherson, and Luhansk, according to open reporting. The Donbass was annexed by Russia in February of 2022, just days before its invasion. The purpose of my capstone project is to conduct predictive analysis within Ukraine using multiple variables to determine which areas are at risk for occupation. Geographic factors and how they interact with rebel fighting forces and state actors play a crucial role in determining the duration of a conflict. Empirical analysis finds that rebel fighting capacity and geography are relevant. Predictive analysis will also be beneficial for possible future conflicts in similar situations. Also, the local population maintains a special significance and serves to legitimize sustained opposition. One of the primary reasons I chose this area of the Donbass is because, according to certain studies, conflicts where rebel forces have access to an international border are twice as durable as other conflicts. And the Donbass is obviously on the Ukraine-Russian border. In order to conduct this study, I will use geospatial statistics to generate a machine learning random forest method algorithm in order to predict the potential risk of an area being targeted within the Donbass region of Ukraine. The kernel density method will be used to convert the conflict location data from point to raster and also identify hotspots. The random forest method is derived from a combination of a large set of decision trees. Each tree is trained by selecting a random set of variables and a random sample from the training data set. The raster data set of conflict data will be given a specific value of 1, and areas where there's no conflict data will be given a value of 0. From that data set, sample points will be obtained at random. This is a photo of a similar study using a different data set. So this is the Global Terrorism Database. I'll be using ACLID, the Armed Conflict Location and Event Data Set, and I'll go into that a little bit later. However, the process is almost identical. In order to perform the random forest algorithm, I need to have driving factors that may increase or decrease the risk of an area due to geopolitical factors. As mentioned earlier, the conflict data will come from the Armed Conflict Location and Event Database, also known as ACLED. ACLED comes from open source reporting and divides events into categories of battles, violence against civilians, explosions, remote violence acts, protest, and strategic developments. The geopolitical factors that will include labor force, population, and gender, migrant stock, internally displaced persons, refugees, food security, and poverty rate. All of these variables will be taken in consideration and used for the study from 2014 to 2022. I will build a relationship between the conflict events and the geographic variables at the spatial scale based on the random forest package within the R environment. In order to complete this project, I will gather data from multiple reputable sources, ACLED, World Bank, and the Humanitarian Data Exchange. I will need to ensure that each of my data sets has a yearly recording of data starting from 2014 to 2022. For the research, I will continue to find articles of prior case studies that perform similar analysis on either crime or state actors in war. My literature review will focus on publications that determine the motivation behind a country occupying an area in contested areas. This is a visual representation of my workflow and results. I need to gather administrative as well as countrywide GIS layers for boundaries. I also need to compile and clean all my geopolitical and demographic layers. The attack conflict data will come from ACLED and be converted from vector to raster in order to run the RF algorithm. The final result will be a yearly predictive analysis hotspot map along with an associate chart showing the frequency attacks in each oblast. Since there is an active conflict, I can overlay the predictive analysis for each year with updated maps to determine the accuracy of my results. The software packages I plan on using are both ArcGIS and RStudio. The biggest goal of this project is to use it as a lessons learned for policymakers. Many regions in the world experience conflicts almost on a daily basis, and many state actors contribute to this. Looking at this from a geospatial perspective allows me to understand why certain areas are picked and if they are essential to the strategic goals of the occupying force. For my results, my anticipated results are that the areas immediate surrounding the Donbass will be, with similar geopolitical variables, will be high risk for possible conflict. My second hypothesis is that Ukraine's large cities will be the next hotspots due to their similarities of the Donbass. The publication that I found that took the global terrorism database information identified areas in the Indochina Peninsula that could be targeted for future terrorist attack. I believe this study is the best model for performing my analysis. In the carrot package for RStudio, I'll be able to measure which feature from the multiple geopolitical factors contributes the highest to the results and which one's also the lowest, whether that be population, gender, refugees, IDPs, etc. So since I'm already technically in 596B, I've started my data analysis and will continue it up until April. That's my projected timeline right now. About mid-April, I plan on compiling my results with an anticipated date of early May to finalize them. Since I'm currently in Europe, I would like to take advantage of using overseas venues. So the two that I identified are both the Geospatial World Forum and the FOSS4G. So those of you that are unfamiliar, the Geospatial World Forum is a collaborative and interactive platform that demonstrates the collective and shared vision of the global geospatial community. This year it's being held in the Netherlands. And then FOSS4G is the free and open source software for geospatial conference that advocates for obviously free and open source software. So those are the two that I'm looking at currently because they line up with my timeline the best. So here's my current reference slide with a small snapshot of the literature used to build my research. And thank you for attending the brief, and I look forward to the conclusions pending anyone's questions.
Thanks, Grace. Does anybody have any questions? Just quickly while anybody else is typing, I was just curious about how your, I guess, proposal has evolved since this is all happening in real time as well.
So the biggest, unfortunately for Ukraine, but fortunately for this research project, because it is in real time, I think that I can build a better accuracy assessment as to like how my predictions are lining up with where like Russia is pushing into these areas. So I think that that's a very unique situation that I wouldn't normally have, or I'd have to like do, if it was a different area, I'd have to use some sort of like historical deep dive. Given the ongoing war in Ukraine and your approach, can you discuss how human behavior could be integrated into your analysis as a factor? Human behavior is a controlling aspect, but probably difficult to model. Yes, so the one aspect of human behavior that I maybe use as a variable is the support, I guess the internal support of Ukraine and their views on whether they are pro-West versus pro-Russia. I don't know if that answers your question, Fritz, but that was kind of the human behavior approach that I was going for. What are some of the limitations you've encountered with event data like these? How do they handle location issues where multiple places are potentially relevant to a specific event? Example given, the location of an attack versus location of the organization responsible for the attack. So the limitations would be, obviously, if it's only coming from one source, it may have the tendency to skew it. So that would, I think a way to mitigate that would be to use multiple sources. So I could use both ACLED and GTD. The only problem with that would be that the global terrorism database only goes until, I believe, 2020 right now. I might be able to get 2021, but I wouldn't be able to get this past year's. So the biggest limitation for me is finding data sets that line up with the exact timeline I want, which is 2014 to 2022. So if there's no more questions, I can put my email in the chat.
Great, that's what I was just gonna say. Thank you very much. Excellent. Thanks again. And we will move on to our last presenter. And that is Danielle Schaffeld. And Danielle, whenever you're ready, you can go ahead and start. I think I can hear you, Danielle, but do you see the little share screen?
Yes, I'm sorry. I lost my screen when I went to switch to my presentation.
No problem. More patience.
Here we go. Let's see.
Here we go.
There we go. Okay. All right. Well, good evening, everyone. I'm Danielle Schaffeld, and I guess I'm the last presenter for the day. For my capstone project, I am looking at stormwater management systems in Athens, Ohio, particularly experimenting with LiDAR intensity to improve impervious surface classification in areas of dense tree canopy. Sorry, that's quite a mouthful. So before we get too much farther in, I'm going to start off by giving a quick overview of what I mean when I say impervious surface. So an impervious surface refers to all hard surfaces such as paved roads, parking lots, roofs, and highly compacted soils that would prevent the natural soaking of rainwater into the ground. Runoff from impervious surfaces is a concern in many urban areas because the increase in impervious surfaces have in many cases outpaced the construction of stormwater drainage systems capable of handling them, resulting in flooding and erosion, pollution, particularly gasolines, oils, and fertilizers getting into the water table, and maleffects from heat retention, such as stressed ecosystems from high water temperatures and the formation of urban heat islands. In particular, there is ample evidence linking impervious surfaces and flooding. So according to one study I read, for every percentage point increase in roads, parking lots, and other impervious surfaces that present water, prevent water from flowing into the ground, annual floods increase on average by 3.3%. Clear correlation there. So finding ways to maintain the balance between stormwater runoff from impervious surfaces such that flooding and pollution are reduced to acceptable levels is a key part of environmental engineering. This was recognized in 1987 when the National Pollution Discharge Elimination System Stormwater Program was created as an amendment to the Clean Water Act. The NPDES requires municipalities to develop a stormwater management plan to reduce pollutants in the stormwater discharge to the maximum extent practicable. Just a little ambiguous. Unfortunately, this system places the responsibility for funding stormwater management policies squarely on local municipalities. These areas, in particular, my area, are often operating under tight budgets. And as a result, the development of sustainable stormwater management is often put on hold in favor of more immediate concerns, such as law enforcement and education. And oftentimes, what money does come from the stormwater is used to fund other budgetarily stressed programs. So the most common methods of generating stormwater management funds is through stormwater utility fees, with additional funding being obtained through state or national grants. The most common types are the equivalent residential units, equivalent hydrological area, and intensity of development, which all use impervious surface per parcel in one way or another to calculate the amount that would be owed. One 2017 case study by Federchak and others compares 8 methods of stormwater calculation and found that there's a clear correlation between the burden contributed and the amount paid to offset the burden when using methods based on impervious surface. A corollary is that this method tends to favor residential areas and place a heavier burden on industrial areas. However, many locations choose to implement a flat rate instead, simply due to financial cost of providing accurate impervious surface calculations, which is where an effective GIS system would be very useful. So I'd like to move on to discussing my area in particular. So real quick, just a little bit of background about Athens. It is, I think I said, located in southeastern Ohio, in the bend of the Hawking River. Its one claim to fame, if you can call it that, is that it's where Ohio University is, which is where I did my undergraduate work. A large portion of it is situated on floodplain, and I can tell you from experience that the South Quad floods frequently. As you can actually see in this photo from 1968, when the entire South Quad was flooded, and I heard that people were going to class in canoes. But as a result, two severe back-to-back floods, funding was acquired from Congress to improve the Hocking River channel through the Athens Local Protection Project. These improvements consisted of realignment, straightening, and enlarging large portions of the channel, widening the bottom. There was also a reservoir placed some miles upstream, which provides some additional security. It was completed in 1971 and was originally projected to have a design level protection of approximately 60 years. But further research indicates that that's actually not quite right, and that 40 to 50 years is a more appropriate estimate, which means that the design is up as of 3 to 10 years ago, and the need is more urgent than ever to install a new program. So in 2017, the City of Athens instituted a stormwater management program that was meant to locate unauthorized sources of pollution and also to educate the public about the sources of pollution and try and generate interest in correcting it. So the benefits of a GIS system for impervious surface calculation is, well, primarily the low cost. If you use an object-based image extraction method, you can reduce the cost in time and labor, and that would allow for an increase of funds to be funneled where they should go into actually providing a solution. It also uses publicly available data generated from state or national funding, which provides additional value to those data sets, and also works to keep the cost down. The lower cost of production could allow for the potential switch over to an impervious surface per parcel method of generating a utility fee, stormwater utility fee, which could in turn increase monies generated. And then finally, I hope in the end to make this be largely automated. So the cost of upkeep I would predict to be low, and the system for updating it would be built right in. However, these benefits can only be realized if the impervious surface can be reliably extracted throughout the entire study area, including areas where the tree canopy obscures the impervious surfaces. As you can see just in these two side-by-side images, this is pretty typical of the residential areas of Athens. The image on the left was collected in summer while the leaves were full, and even in November when it's mostly leaf off, but a few deciduous trees are still hanging in there. But you can see that there's definitely quite a bit of impervious surface that would have been missed simply looking at the image on the left. And you can also infer that there is more beneath even just the canopy that is there when the leaves are down. So the goals for my project would be first to establish the effectiveness of LiDAR-derived products, particularly intensity, in increasing the accuracy of impervious surface extraction. And of course, as I had mentioned before, to try and keep the costs down as much as possible. LiDAR is effective because it can penetrate the tree canopy, whereas the aerial imagery cannot, of course. Okay, so here's a quick run through of my methodology. I began with the data preparation, which took a bit longer than I had anticipated. So the imagery used, I used 1 meter, primarily NAPE imagery from 2017 and 2021, and I was able to find 6-inch aerial imagery from 2014 and 2020. LiDAR from 2021, there was more that existed from 2007, but that was not particularly useful. Once all the data was gathered, I had to convert it from Mr. SID into an image or TIFF format to make it useful. And then I experimented with several different LiDAR-derived products to create as many layers as possible that would be useful in constructing the surface beneath the tree canopy. In particular, I looked at the NDSM, the slope NDSM, and intensity, and I also played with the returns. I found the ground and final returns to be the best, as they largely excluded the vegetation. One thing I found was that some LiDAR data sets are better classified or more particularly classified than others. So in some cases, the buildings would already be in their own class, and in others, such as this one, they were actually just unclassified. They only classified the ground and vegetation. All right, so once all the data was prepared, I selected a test area to use for training my model. The entire area that I want to use is pretty large. It's about 12 square miles. So each of these square blocks here are mile by mile square blocks. So the first thing I did was select a test area to develop the rule set to be used in eCognition. And then I performed segmentation separately on the buildings and roads. Two methods that I found to be particularly useful were the contrast slit method and the multi-threshold method. Both of those two were used to classify the buildings on separate levels. And then the roads were classified using the multi-threshold method and a road vector layer created from the road center lines. Okay, once everything was segmented to the best that I could get it, I classified the data. I found that the most useful classification parameters were intensity, NDVI, area, and then region grow was also very helpful for expanding the roads. And once everything was finished, I exported it to ArcMap to calculate the percent impervious per parcel. And here are the results. Here. So what you see here is a comparison of, for want of a better term, I'm calling the model accuracy and the absolute accuracy. The model accuracy here is referring to how well the rule set performed based on the information given to it, while the absolute accuracy describes how well the model fits reality. The absolute accuracy values were determined based off of a survey, which I got some very patient people to help me with, where each person was provided with several figures, including the NAPE images, the high resolution images, and the intensity rasters, and asked to indicate whether they thought when the canopy was removed, whether the ground surface would be impervious or pervious. So for example, on the left, we see the results of the leaf-on accuracy assessment. The rule set given works fairly well with an overall accuracy of 96%. However, we can see that if we compare this to what was estimated to be the true value of the point, the overall accuracy is much lower, 85% overall, and only 27% for the producer's accuracy for the impervious class. And that was 24 in the leaf off. So yeah, similarly, the overall model accuracy of the leaf off data set, which is comparable to the leaf on model accuracy, drops from 90 to 85 absolute overall accuracy. And so the point of comparing these two metrics is to demonstrate just how much impervious surface is obscured by the tree canopy in particular regions. By comparing the producer accuracy of the overall accuracy of each data set of each map, it's evident that the overall accuracy remains relatively consistent. The number of correctly classified impervious surfaces doubles when using the intensity-based raster. So it goes from 24 to 27% to 55%, which is still suboptimal. It's lower than I would want it to be, and I still clearly have a lot to improve with my model, but it is demonstrably better than simply using height and aerial imagery. Okay, so I feel that the primary strengths of the model were that some of the areas that were included did end up being included in the final data set. In particular, you can see this road up here in the northwest was included, and this area here going up to the northeast and down here. One particular region that gave me no end of grief is this north-south road right here. It's my eternal foe. Another strength is that the classification completes in a timely manner on my fairly average computer. I think that the primary weakness is that the producer accuracy is pretty low. Some future improvements that I think can improve the statistic is to focus on shape, particularly using the parallel lines method to clean up the building class. And I really think that better raster preparation could be beneficial, particularly removing speckling from the last return intensity. And I also noticed some areas where there was noise that seemed to correlate with where the swaths overlapped. And I did do a little bit of research. It seems like you can correct for this to some degree. So I would like to experiment with that. And then there has also been, it's also been demonstrated that a false NDVI could have potential. And then finally, the end goal would be to expand and automate the final rule set using eCognition's Python interface. This would allow larger regions to be classified without using eCognition server, which is a bit expensive and would not hopefully provide additional abnormal wear and tear on the CPU. So my end goal would be to extract the impervious surface location for each of these 6 mile by mile blocks and combine them for my final end product. And that's everything. If you have any questions, comments, please let me know what you think.
Great, thanks, Danielle. If anybody has any questions, I want to just put a couple down there. But anybody else who has questions, please type them in the chat.
Let's see. Oh, you grew up in Athens. Oh, wait, sorry. What are some strategies to improve impervious surfaces? So are you talking, Beth, are you talking about like make improvements to the physical landscape or to make improvements to the extraction method?
I think it's a more general question that's not really associated with you identifying the area. So this really probably isn't part of your proposal. I was just curious, since it was in your title, I was wondering if once those areas are identified, what's a strategy to help solve the problem of the stormwater runoff?
Well, I mean, primarily this is meant to provide data for other people to figure that out, but some things that I had run into, for example, in Cincinnati, just over to the west, there's been talk of replacing parking lots with that are smooth paved surfaces with gravel. And providing additional tree cover where they can. So even if you can't take out the entirety of the surface, just plant more trees along the edges or in the centers to try and reduce the heat. Let's see. Athens, I know the east, that is a greater amount. Yeah, I mean, I would love to expand this and to other parts of Athens. Ideally, this would work with anything that is using the same LiDAR sensor, since it primarily relies on the LiDAR data set. I think as long as the sensors are similar, hopefully I've got a large enough region with what I'm working with that the rule set will be flexible enough that you can get, I mean, maybe I'm being optimistic, but maybe 85% of it correctly identified, which would decrease the manual labor quite a bit. Also, I'm not really familiar with a thermal absorption difference. Ross, I wish I could. So that's something else that I would need to look up. Oh, you went to OU. Oh, my aunt actually also teaches there. Yes. Were there any further questions? And Ross, I'd love to hear more about the thermal absorption difference. Yeah, I'll definitely have to look that up.
Sounds like a good reason to put your email address in the chat.
Yes, I'm sorry. Yes, here we go.
No, that comes at the end. So that's perfect. So maybe the two of you can continue that conversation.
There we go.
Okay, excellent. Well, thanks so much for that, Danielle. And we will conclude for the evening. We have 2 more days of presentations. They're both in the afternoon. Well, I guess starting in the morning at 11 a.m. Eastern tomorrow and Wednesday. So we would appreciate you all coming back if you can. As I said there in the chat, these are obviously being recorded and we'll put them in the capstone library. And there is the link to the peer review evaluation form. So thanks again, everybody. Great job. And we'll see you tomorrow.